we will read electrical circuits. In electrical circuits are actually of two types, series circuits and parallel circuit. Before we go to series circuit and parallel circuit, we need to know some devices or components which we will connect in series or parallel circuit. So let us introduce with some components or devices. Switch can be like this. It's open switch. There is no connection. Open means no connection. And this is a switch that is closed, the connected one. In both terminals are connected. Cell, the symbol of cell is like this. Two bars. One is bigger one is a smaller one. There are many cells together. Dot means, there is a dot means many cells together. It's a battery. Two or more cells together, we tell it battery. When two or more cells are connected in series together, we call it battery. So you see here, dotted line means there are two or more cells here, they connected together, so we call them battery. This is a diode. This is a symbol of a diode. Diode, it can pass through current only in one direction. It can pass through current only in this direction, not this direction. If current comes from this direction, it does not allow current to pass through. So only this direction. So this is the symbol of diode. This is the symbol of resistor. This is the symbol of a variable resistor. Variable resistor means the resistance value can be changed, it can be increased or it can be decreased. The symbol of a bulb. Generally, a bulb does not look like this. This is the symbol, electrical symbol. In electrical circuit, we can draw a bulb like this. That is called symbol. A fuse look like this. Is the symbol of a fuse, just like resistor, but the line, it goes straight through it. It's a voltmeter symbol that you know already. It's ammeter symbol, it's a thermistor, and it's LDR, light dependent resistors. So you have to remember all these symbols. It's a very important one. Especially look at this switch. It's open and closed switch. Now we move forward to series and parallel circuit. So what kind of circuit is series circuit and what kind of circuit is parallel circuit? This is the example of a series circuit, and it's just like a loop. Look at this. This is a positive terminal of the cell, the negative terminal of the cell, and current comes from the positive terminal. It goes through the bulb. It comes from the positive terminal. It goes through the bulb like this, and it comes to the negative terminal. So when current from the cell, current comes out from the positive terminal of the cell and it reaches to the negative terminal of the cell, we call it a complete circuit. So this is a complete circuit, and this is just like a loop. In a single loop, all the devices or components are placed, and this is called series circuit. I repeat once again, current comes out from the positive terminal of the cell and through the wire, and the lines drawn, these are line, these are this line, this line, these are wires, these are wire. So when current comes out from the positive terminal through the wire, this is switch. It's closed switch. It means on. Switch is on. Through the bulb is lighted on. Another switch. This switch is also on, so current can go through the bulb, through this bulb, and another switch. It is also on, so current can go through. Means there is a connection. On means there is a connection. Now current through this wire, it reaches to the negative terminal. So current from the positive terminal through the wire bulb switch, it reaches to the negative terminal. It forms a closed loop, and on the loop, each devices or components are placed. This is a series circuit. This is a series circuit. And now look at this. This is a positive terminal of the cell and this is the negative terminal of the cell. Current comes from here. Just after reaching here, current finds that there are two ways to go. One is this way and one that is downside. So current divides. One goes this way and another goes this way. So it goes this way, this way, this way, it comes here. And this current just reaching here, it finds that there are again two ways to go. This is one way, this is another way. So this way again current divides. This way one part of the current, it goes this way, another part, it goes through this way. Now here, these two currents, they meet here. They meet here, they join, they combined. So addition of these two currents here, the combined current goes here. Now here they found this current. These two currents again joined here. And the combined current or addition current, they go through here. Final current, this is the resultant current, the current that comes out from here. And this value, it's same. This one and this one, it's same. So it reaches to the negative terminal. Now look at this. This is one loop. This is one loop. This is another loop. And this is another loop. And all these loops are branches. And which was called branch? From here to here, this is one branch. From here to here, this is another branch. And from here to here, this is another branch. And the three branches are connected with the cell parallelly. This is called parallel combination. Just like red line. Have you seen red line in your life ever? So this is the red line combination. So this is the parallel combination. That's why this circuit is called parallel circuit. And this is called junction, when the currents are divided and when the currents are met once again. These are called junctions. So a parallel circuit contains one or more junctions. Parallel circuit contains more branches, two or more branches. Series circuit contains no junction or branches. So we got some important things to note. Series circuit contains no junction or branch. Parallel contains junctions or branches. So you understand what is called junction and what is called branch now. And remember that a cell or battery, there must be connection from positive terminal to negative terminal so that current can flow from positive terminal to negative terminal. There must be connection from positive terminal to negative terminal. If the connection is like this, look at this, for example, somewhere like this is a switch, and if it is drawn like this, the switch is open. Remember, this is open switch we have seen here. This is open switch. Look at this, open. So if the switch is open like this, then current cannot go through. Current is stopped here up to here. It comes from here and up to here. It cannot go through. It cannot pass through because there is no connection here. But our connection, our switch is closed. Now we can get some other properties of series circuit and parallel circuit. This is a simple series circuit and this is a parallel circuit, and it has 4 branches. Series circuit, one switch placed anywhere in the circuit can turn all the bulbs on and off. It's a very important one. In a series circuit, one switch is enough. Here there are 3 switches. It's not necessary. One switch placed anywhere in the series circuit can turn the bulbs on and off. If one bulb breaks, if this bulb breaks, the whole circuit breaks. So if this bulb breaks, then also whole circuit breaks. It means that in a series circuit, if one device does not work, one device or one component does not work, the whole circuit fails. It cannot conduct any more electricity or current. But in parallel circuit, it does not happen. If this bulb does not work, current can go through other branches. So this is the first line that you must mark. It stops working. And energy supplied by the cell is shared between all the bulbs. So the more bulbs you add to the series circuit, the less bright they all become. So from the energy is coming from the cell, you know, the cell has, like, if the cell is like, for example, so 1.5 volts. And what does it mean? 1.5 volts means, we read before, 1.5 volts means 1.5 joule of energy is given to each coulomb of charge. 1.5 joules of energy is given to each coulomb of charge. So 1.5 joules of energy given. Now, this energy, if you add more, this energy is divided into these bulbs, this one, this one, this one, this one. It's divided. If you add more bulb, another bulb, it will also get some energy and their energy will be reduced. If you add another bulb, it would also get some energy from here and their energy will be reduced. So more bulb you add, more less brighter they become. They become dimmer and dimmer and dimmer. So energy is shared. You understand? Energy is shared in a series circuit. So we can underline this. So these are some properties of series circuit. Now look at this parallel circuit. Switches on can be placed in different parts of the circuit to switch each bulb on and off individually or all together. So switches can be placed in different parts. If you turn off this switch, if you turn off it, this is S1, if you turn it off, open, what would happen? S2, S3, S4, they are on. So this bulb will light on, this bulb will light on, this bulb will light on, but this bulb would not light on. Because current can flow from like this. Current can flow from like this. From this terminal, current can flow like this. But what about this? Current comes here, here, and now current finds that there is no connection and current cannot then go through this bulb. That there is no connection, current would not come out from the positive terminal. Current would not come out from the positive terminal because there is no connection. Current knows that there is no connection here on the line and I cannot reach the negative terminal. So current would not come out from the positive terminal at all. So this bulb would not light on, but these three bulbs. So by placing switches on each branches, we can control this bulb to turn off and this bulb to turn on, this bulb to turn on. So we can place switch in each branches and we can control each bulb by each separate switch. This is not possible in series circuit. Then if one bulb breaks, only the bulbs on the same branch of the circuit will be affected. If there is one bulb goes off, no problem for the other bulbs. For example, this bulb suddenly it is not working, it damaged. So this branch, this bulb damaged means this branch is damaged. This branch would not work, but remaining branch would work. They will light on because current from this branch, from here, it will go like this. Current from again from here, it would go like this. current from this terminal again through this bulb, it goes like this. So remaining three bulbs would work. They will turn on. They would not be affected, but this branch, because this bulb fused, for example, or this bulb, it blows out, then this branch would not work. But remaining branches, no problem to them. Remaining bulbs, no problem to remaining bulbs. They will also light on. They will give light. Simple, very simple concept. This is the advantage of parallel circuit. Now, look the last point. Let us look at the last point. Each branch of the series circuit receives the same voltage. So if more bulbs are added to a circuit in parallel, they all keep the same brightness. Very important point. Please underline. Each branch receives the same voltage. I want to underline this. Each branch, same voltage. Just now look at this. It's a parallel connection. Look at this cell. This connection, this cell has direct connection with each branch. This branch, 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 and this branch. So direct connection. There is no problem of voltage sharing. They all, each branch is getting similar voltage of the cell. So each bulb is getting similar voltage as the cell is supplying. So their brightness would be equal and they would be brighter. They would not get less voltage. If we connect another bulb here in parallel connection, it would also give similar brightness. We can connect other bulbs here. We can connect other bulbs here. There is no problem. So it would give similar brightness. We can connect other bulbs here. There is no problem. So they would give similar brightness. This is the advantage of parallel circuit. So this point is very important. Each branch of the circuit receives the same voltage. So if more bulbs are added to a circuit in parallel, they all keep the same brightness. No problem would happen. There are some other informations are given here, that like decorative lights are often wired in series. You know, in decoration during marriage anniversary, we decorate our buildings. So there are many small bulbs are connected in series. Just if you just turn on the decorative light, that symbol is given, the picture is given here. If you just switch on, that's one switch can control all the lamps, all the lights. They're in series. But what happens if one goes off? The problem is that if one goes off, the whole series, all the bulbs will go off. That's why there is an additional wire is given parallel, so that if one bulb goes off, with that additional wire, there must be a connection so that electricity can go to the next bulb and to the next bulb and to the next bulb if one goes off. But generally, electricity does not go through that wire because that has a bit high resistance than the bulb. So current, it always follows low resistance path. So it goes through the bulb naturally. If one bulb goes off in a decorative light, then current goes through that parallel high resistance path to the next. Current in a series circuit. In a series circuit, look at this. In a series circuit, current remains same in all parts. Current is 0.2 ampere here. Here is 0.2 ampere. Here is 0.2 ampere. Here is 0.2 ampere. Here is 0.2 ampere. So current is same. Current is same in all parts of the series circuit. And the current depends on the voltage supplied. If the voltage supplied is bigger, current is bigger. So size of the current in a series circuit depends on the voltage supplied to it. If the voltage is increased, current would increase. And current in parallel circuit, look at this, each branch, they have different currents. Current is coming 0.6 ampere from the positive terminal, and this branch 0.4 ampere goes through this branch and 0.2 ampere goes through this branch. So currents are divided in different branches. Current divides into a junction. This is called junction. Do you remember? Current is divided into a junction coming into the parallel circuit. So different parts, different branches of the parallel circuit have different currents, different amount of currents. So, and different branches have similar voltage, and different components in a series circuit, they have different voltage drops across them. They consume different voltages. The devices which are high resistive devices, they consume greater voltages than low resistive voltage components. So this is all about this chapter. We can get a review what actually we learned in this chapter. We learned at first electric conductors, insulators, and electric current. Then we learned Q equals to IT formula. Q is the charge, and 1 coulomb of charge means 6 multiplied 10 to the power 18 electrons. We got another formula just like E equals to Q multiply V, and Q equals to IV. So we can also extend this formula equals to, if we put Q equals to IT, I multiply T multiply V. So equals to ITV. And we can further extend equals to, I and V is P. P multiply T. I and V is P because P equals to I multiply V. So if we put I and V equals to P, so we got E equals to PT. So we got some other extension formulas. These are important. Please get this note. Then we have found voltmeter, which must be connected parallelly across a component in a parallel circuit. We got ammeter to connect series in the series circuit. We learned different components and their symbols. We learned series circuit, we learned parallel circuit, and we got some points by which we can differentiate them. Now we can write the differences between series and parallel circuit. This is also important. So students must make a note by themselves using these points. Write down the differences between a I can say the differences in short form. For example, a series circuit, current remains in a series circuit is same, but in a parallel circuit, current in each branches are different. In series circuit, the voltage is shared between the components, and each component gets or drops different voltages. And in parallel circuit, all branches receive similar voltage. So all branches get similar voltages as the supplied voltage. Then in series circuit, one switch can control all the components, and in parallel circuit, different switches are placed in different branches. So each branch can be controlled individually. In series circuit, if one component goes off, the whole circuit breaks. But in parallel circuit, if one component goes off, then is the problem only that branch, not other branches. Components in other branches can work properly. So these are some basic differences between series circuit and parallel circuit. And if you read these things more, it will be more clear to you. And so I request you to read these topics and things properly at home so that you can understand better.